What we'll be working with today is very basic characteristics of functions. We're going to be talking about increasing, decreasing, and constant functions, and determine local minimums or maximums, which are also called extrema. So a minimum or maximum value, what that means is that in that local area, those points around that area, we have a minimum value. So if we look at this graph here, I think we can all agree that this maximum is higher than that point here, but they're both called relative maxima or maximums because around that area, it is the maximum value. And around this area, that is the maximum value. Like I said, we can all agree that that point right here would be the highest on the entire graph, but this here is also a maximum because it's like around that area, it is a maximum value. We call that a local maximum. And we also have the same idea for minimums down here. Local minimums or relative minima, where around this area is a minimum value and around that area is a minimum value as well. So we're looking for peaks or troughs, tops or bottoms, and that is when we would have a minimum or maximum value. Another way of thinking about these is when you have a change of directions. Another way of thinking about these is that for maximum, if our function is going up, okay, and then it goes down, okay, it changes directions from increasing to decreasing, that's a maximum value. Or if our function is going down and then it changes directions to increasing or going up, then we have a minimum value. So if our function changes directions from increasing to decreasing or decreasing to increasing, we have a minimum or maximum. So let's review what does increasing or decreasing mean. So when we're reading a graph from left to right, you can determine the behavior of the function, if it's increasing, decreasing, or constant, by looking at what the y values are doing. Okay. The y values, again, are vertical, up and down. And since we are reading our graph from left to right, the x values will always be increasing, but the y values, that's the important part. So if we look at this graph here, reading it from left to right, our y values get smaller and smaller, so we're decreasing. Then right here, our y values level off and they stay the same. We would call that constant. And then over here, our y values are increasing or going up, so we would say that the function is increasing. That's different than saying we have positive y values. If we look at this whole graph, this whole thing, the y values are all positive. Our smallest y value is 1, and our biggest y value is 4. So every y value in this function or this graph is positive, but we have a decreasing section, a constant section, and an increasing one. I know it doesn't seem like it, but from my experience, it is an easy thing for students to mix up the difference between decreasing and having positive y values. You can have that. So we're going to get our graphing calculator out and determine what relative minimum or maximums or local extrema we have over the intervals, and then also tell when each of these functions are increasing, decreasing, or constant. So we're going to graph these functions. So y equals x to the third minus 3x squared minus 1. Oops, I need a squared, 3x to the third. Okay. So when we graph that, we have our function increasing, then it decreases, and then it increases again. So we have a maximum right here and a minimum right there. We need to figure out where those points are. So we do our second trace that we did last year. For finding a minimum, we go to minimum. If we go to maximum, if we want to find that. So we go to the left bound, hit enter. Go to the right bound, hit enter. So this right here, negative 1.454 e to the negative 6, that's really close to 0. So what we're going to do is we're going to call that 0, negative 1. So we're going to draw a rough sketch to help us. So 0, 1, we had a maximum. Then it's going to come back down. So we're going to do second trace minimum. And we have 2, negative 5. Okay. So we come back down to this point, and then we come up. So this point right here was 2, negative 5, and this point was 0, negative 1. So we are increasing from negative infinity all the way up to this maximum point. So negative infinity, 0. And from this point going up. So and 2, positive infinity. We are decreasing, and we can abbreviate those in the next problems. We're decreasing in this interval from 0 to 2. So we have 2 intervals of increasing and then 1 interval of decreasing. So we were also asked to label the minimums and maximums. So the max would be at 0, negative 1. And the minimum would be at 2, negative 5. And if we look at example 2, we have x raised to the 2/3 power, and that graph looks like this. So like a weird looking V, but there's a little bit of a curve to that. So it kind of looks like this. So I think we can probably tell that the minimum is going to be 0, 0, but let's double check. So minimum, yeah, this is scientific notation. And if you were to actually write out those numbers, it'd be really close to 0. So our minimum value would be 0, 0. We don't have a maximum. We don't have like a crest or a top. The function just keeps going. And then we have our intervals of increasing and decreasing. If we look from left to right, the y values are going down, so they are decreasing from negative infinity to 0. And notice that we're using parentheses for all of these intervals because you're not including these points. We don't need to do that. So then we're increasing from 0 to positive infinity. Right now on the next page we have a couple more complicated looking ones. So we're going to do absolute value. So alpha window, absolute value of x plus 1 plus the absolute value of x minus 1. And then it looks kind of like a U, but we have this area right here where it's a horizontal line. So it goes like this. So we need to figure out our intervals of increasing and decreasing. So we got to figure out those 2 points there. Now, those are, you could look at that and say those are bottoms, but they're not minimums because look at, that's not the lowest value in, if we circle that, that's not the lowest value. We get down to that y value and we stay constant for a while. So that's not a minimum for us to list, but we need to figure out what the coordinates of that point are. So we can't use the calculator to calculate the minimum of this graph because we have this whole stretch where the y values are 2, and then we go back up. So what we want to try to figure out is when do we change directions? Our y value is 2, and now our y value is bigger than 2, and we can probably assume that it's going to be -1 and +1 just because the absolute value bars both have x plus 1 and x minus 1. So these 2 points are going to be -1, 2 and +1, 2. So we have an interval of decreasing y values, or decreasing y values reading from left to right. So decreasing would be from -infinity, -1. Constant, we have a constant portion of this graph from the x values of -1 to +1. And then we are increasing our y values in this portion from +1, infinity. We don't, like I said, we don't have a minimum value because a minimum value is a point. This point is not a minimum because this whole section here has y values that are equal to 2. Okay, then let's look at this last one here. So we have x times the square root of x plus 3. So notice that our x values, or our function, starts at -3 because we can't have the square root of a negative number. And then our function hooks down a little bit and then starts to increase. So we need to figure out where this little hook is. Let's draw a graph. And we know that this point right here is at -3, 0. And we know it would come down and then up. So we need to figure out the coordinates of this minimum here. So second trace minimum -2, -2. So we have an interval of decreasing, the y values are going down from -3 to -2, and we are increasing from -2 all the way to infinity. So being able to look at our graphs and identify increasing, decreasing is super important, and we can calculate our minimum, maximum using the graphing calculator features. The other day, we evaluated piecewise functions by plugging in the values depending on the domain here. Today, we're going to graph them. So when we graph them, what I like to do is I like to graph the whole function and then erase what's needed. So what I mean by that is I'm going to graph 2x minus 3. 2x minus 3, we go down 3, and then 2x is up 2, and right 1. So I'm going to graph this line, but I only want my x values to be less than or equal to 1. So I'm going to go back and erase this part here because my x values are greater than 1 over the interval I just erased. So all these x values now, from here to here, all these x values are less than or equal to 1. Now, the second one, my quadratic, that's x squared. We know that x squared starts here and will look like this. But again, we only want x values greater than 1. So from here, I need to erase everything that's less than that. And because it is less than and not less than or equal to, we would have an open circle there. And this is what our piecewise graph would look like. It's okay that they don't connect. Very rarely will our piecewise functions connect when we graph them. But we should not have any overlap. We should still pass the vertical line test. If I draw a vertical line, I'm not going to touch both my red and green part, except right here, but we have an open circle and a closed circle. That's okay. So then we can evaluate these. Evaluating f of 3, well, f of 3 means we're going to use the second function. So f of 3 is going to be 3 squared, which is 9. F of 1, well, 1 is less than or equal to 1, so we're going to use the top function, 2 times 1 minus 3, which is negative 1. And then f of negative 2, we're going to use the top one again. So 2 times negative 2 minus 3, which gives us negative 7. So these piecewise functions, evaluating them isn't difficult, but graphing them can be, just because it's a mess to erase things. Now this one, we have x minus 1 when x is less than or equal to 1. So x minus 1 means we're going to start at negative 1 on the y-axis and go up 1 and right 1. The slope is positive 1. But we only want x's less than or greater than 1, so we need to erase this part. Then this function, x minus 4, so down to negative 4, 1, 2, 3, 4, and our slope is still 1. So our line looks like this, but we want x to be bigger than 1, so we're going to go and erase everything that doesn't fit, or that's smaller, and make sure we have that open circle there because it is less than, it is greater than 1. All right, so that's it for this video. The main idea was to really be able to look at a graph and tell when is the graph, and if I say when, 99% of the time we're talking about x values. So when is a graph increasing, when is a graph decreasing, or when is it constant? You know, like here, our graph was decreasing when x was going from negative 3 to negative 2, and then our graph was increasing from negative 2 to positive infinity. That is the main idea that we're trying to get across here. And then these piecewise functions, you're graphing both functions and then erasing what isn't needed. So thanks for watching. Make sure to like the video and subscribe.